Hello everyone and welcome back to Syntasa training series. This particular video is intended for users who have already gotten used to this platform and the application. In this video, we will continue to explore the fraud detection problem using machine learning. If you have seen some of our previous lessons, you would have certainly come across some of the ML learn processes that Syntasa provides out of the box. These processes are helpful for data scientists when solving business problems using machine learning and AI because they are low code processes and they are built keeping production grade systems in mind. Uh, However, in this video, we are going to explore how to build this machine learning pipelines using uh, Python code processes. So there are many such instances wherein data scientists write their own code and they want to train their own models. And this video is intended to show how can we plug in those code processes to start with data transformation, feature engineering, and then splitting the data, and finally training a model. So overall, getting started with the data, let's have a peek into what the data contains. And we have this data flowing in for 3 months, beginning July uh, until the end of September. So it has transactions on a daily basis. And if you take a look at the preview, you see there is some visitor IDs who purchase some products, and this is the details about those IDs, like browsers. There's the campaigns that they touch upon, how many cart ads did they do, how many cart opens, so on and so forth. And at the end, we have a target column, which is either a 0 or a 1. So in this data set for 2 months, what we have is a very highly imbalanced problem where there is around 95,000 records which are non-fraudulent, and there's only roughly 580 to 600 records which are fraud. So the fraud rate is very low, which is typically what we encounter in our day-to-day basis. So the fraud rate is only 0.6% here. And quickly going on to how to use this data to train a classifier so that we can predict this fraudulent transactions using machine learning. So what is needed at the beginning is that we have the raw data flowing in, and then we are going to do feature engineering on this data set. So what I have done here is I have dragged in a Spark process from the left hand side. So for example, if you search here for a process, you will get this Spark process, and I have dragged in that process, connected this table to this process, and now I am ready to write my Python code, which will help me convert that raw data into a vector format, or a feature vector, which will be useful in downstream analytics. So here is a short summary of this process. It reads the data worth 2 months, as I mentioned earlier, from July to August, and then there is different types of data in our table. For example, there's some numeric data, there is some categorical data. So what we are going to do in this piece of code, or in this process, is that we are going to do normalization on our numeric features, and we are also going to do one hot encoding on the categorical features, because uh, machine learning algorithms need the data in numbers, they don't understand text. So we are going to do one hot encoding on those categorical features, and then what we are going to do is have a custom pipeline to chain the above feature engineering steps. So imagine that you have raw data flowing in for this 2 months, and then you have a pipeline wherein there are steps in this pipeline, and you only need to define those steps, and the pipeline will take care of the rest. So we once we prepare this pipeline, we will fit that pipeline to this data set, and this step will convert these raw features to n-dimensional vectors, and then at the end we will save the pipeline to S3 for a future use. So uh, going through the code, we start with installing some of the pandas libraries and scikit-learn libraries, and here is how you import them, as you typically do in your Jupyter notebook or in your Python script. uh, this is some other imports that I am using later on. But we are going to start by loading the data into what we call as a Spark data frame, and we are going to convert it to pandas. So I'm using a two pandas method, and also notice how I have parameterized this input tables and this dates for which I want to process the data. This is really helpful when we want to train the model for a particular date range, and then we want to score for another date range. So it's all parameterized, and you can have more and more parameters defined in your code processes here, wherein there are some system params that are ready for you to use, like I have used input table for reading the data, but you also can define your own custom params and you can have your own output tables. So all in all, this is the Spark data frame that we are using to read the data from that table, and I'm printing the shape of that data frame and then filling some NAs. But what is important is that I have a target column which I have stored separately as a list, and I have feature columns. So there's many features, but for this video and for this pipeline, I found some of the features which were helpful. So I have only selected a handful of them. So a bounce session, is that session a buying session? How many campaign views? Which campaign did someone take a look at? How many page views, product views, and if the quantity, also the cart ads and the session duration. So if you again take a look at the data, those were the columns which I felt were important for me, and we'll see how does our model perform when we use these columns as features. So uh, overall, there are, as I mentioned, some numeric features and some categorical features. So for numeric features, I'm doing a transformation of imputing them if there's any missing values using the median, but I'm doing a standard scaling on this using mean and standard deviations. So the output, when you see something like campaign view or page views, they would be no longer be in the raw format, but they would be normalized according to the data that I pass. So this is the campaign view, page view in a normalized format in the output. And similarly, I have some one hot encoded variables for the categorical features like campaign. Is that a bounce session? Is that a buying session? Yes or no? So this columns get converted into zeros and ones according to the categories that they have. So if you preview and if you again take a look at the campaign, there are many distinct values in that campaign column. So you see there is a suffix added after the word campaign for each of the columns. So campaign, is that a display campaign? Is that an email campaign or a natural search, and so on. And similarly, we had the bounce session and the buying session. So it's either one or a zero, whether the session was a bounce session or not. So overall, what we have at the end is a transformed data set where we go from numeric and categorical raw data to a transformed data set. But remember that we need to build a pipeline. So I'm using a column transformer to chain everything together, uh, and then create a custom pipeline from it. So this is a scale scikit-learn pipeline, and the it and then I'm trying to fit the pipeline to that data set that I just read in from the table for the 2 months. So what I do is at the end, I also load this transform data to event store, so that I can use it again later on after I'm done with this transformation. So here, if you see, there is a utility that we have in our product, which is write to event store, and any Spark data frame can be written out as a table. So the preview that you were seeing now is something that is written to the event store using that utility. So if I do that preview again, this is what you would have here. And you can also check the state of it, where I have processed this 2 months worth of data from July to August 31st. So we have this transform data set stored. And also, as we had discussed earlier, we need to uh, dump that our custom pipeline to a S3 location. So I'm trying to write some code here where I have parameterized that output location based on our output configuration here. So if I go to this location in S3, I will see that custom pipeline dot pickle file, which we will be using later on to predict that future data. So this is all about feature engineering. And then there is split. So what I do is I want to have two data sets, train and test, where I think I have kept the split ratio as 75 and 25. So I'm reading the transform data set from event store, and then I'm randomly splitting the data into train and test. So and then storing them back again to event store. And I'm going to build my model on the train data, and I'm going to test it out on the test data set. So if you just to do some sanity checks here, the state shows the data being processed for this 2 months, and there is roughly 450 fraudulent transactions out of 70,000 transactions. So again, that fraudulent rate is very, very low. And we are going to do this model training on this train data set and doing the model scoring on this test data set. So let's quickly jump on to the model training. What we have here is another Spark learn process. So I can quickly search that Spark learn process, and if you want to drag in a new one, you can unlock the DAG and drag in a new one and write your own code and train your models. I already have a trained model here, which I'm going to walk through now. So in short, the summary of the steps which are defined in this process, right? So you read that train data set, and that is the 75% of the split that we had in the previous step. And then I am converting that Spark data into a pandas data frame. Then you select your feature columns and target columns, and you do the model training. So there is a library called IMB learn or imbalanced learn in Python, which helps you give several weights to your imbalance classes, particularly in problems which deal with imbalanced data sets. So I am choosing that library here to train a model with uh, a random forest, or rather a bagging classifier with decision tree as the base estimator. So once the model training is complete, then I would upload that model to S3 so that I can monitor that model's performance on my test data or on my unseen data. So again, like, the preliminary steps are quite simple, in the sense you can install your own libraries here by issuing a simple command. And once I have the imbalance learn library, I can start reading the data, the train data, uh, from the event store, and convert it to pandas. And then I have my target variable set, and this step on that you see on the line 54 is where I train a model by choosing a classifier. So this is the balanced bagging classifier with base estimator as decision tree, and I am training 300 such trees here. I can then once the model training is done on this train set, then I'm going to again create a data frame, pandas data frame, and write it out into event store. So and then also save the model to S3. So if you see here at the end, I'm again using a Syntasa utility known as write file to event store, wherein any temporary file can be written out to S3 location. And if you see the parameter, I'm using @learning location as my model output parameter, where my model will be stored to S3. So as users, as data scientists, we can not only write out data into tables to event stores, but we can also save and load our model objects as pickle files or any other files that we would want. And this is really this adds to the flexibility of this Spark Learn process, because now I can parameterize everything and have my models saved and loaded from the cloud directly. So at the end, when you see the outputs, you see the model parameters, and you also have this model name, which comes with this base path. So when you do this model training, you will have this data in the output table. uh, I have called it as model parameters because I want to store and show it how do my parameters look like for this decision tree classifier using bagging that I created. So these are all the parameters, like number of estimators 300 that we had set, and then the sampling strategy was auto. So overall, this table has all the parameters in it, and this object is the classifier model. So remember that I had stored that model to S3, and when I go back here in my S3 location and in my models folder, there's a learning folder there, and there you will have the balance classifier model, where again I have stored my the model as a pickle file. So now we are all set with the model training, and but until we do the testing on the test data, which is the 25% of the data, we would not know so as to how does our model perform on that unseen data. So this is the test set here, and what I'm going to do is I'm going to read that test data set from the event store again and convert it to pandas and load the model from the S3 using that pickle library, and then I'm going to do a dot predict. This is the learning location as I had shown earlier, and I'm downloading the model file from S3, and I'm storing that in my local machine in my cluster. So once I read that test data set for that date range, then I can create my pandas data frame in a way where I do the loaded model dot predict. So I'm using the predict method to generate the scores. Now once the scores are generated on that 25% of the data, then we can run some classification reports, and we can also store confusion matrices for our users or for our team members for which with whom we can share these results. So uh, I am creating a result data set with all the prediction columns, and I'm storing the features as well as the predictions in the output table. And along with that, I am also storing the confusion matrix and the classification report to the output table. So again, this write to event store is a very handful utility in that sense, because all I need is a Spark data frame, and then I can easily write that out to event store. So when you run this job for this 2 months, what you'll get is test set predictions, where if you do a preview, you will get the features along with that ID for which that transactions had been performed. And so this is the ID, this is the actual target, and this is the predicted label according to the model. I'm not only storing the predicted label, but I am also storing the probability of it being a transaction being a non-fraud or a fraud. So and there is a classification report which shows you how good is your model based on the test set scores that are generated. So overall, if you take a look at this table, you see that the precision for low group is very good, which is 99%. And we have started training a model which we can certainly tweak, and we can do a grid search, and we can improve this model. But overall, 57% of recall uh, on the fraudulent one. So the weighted F1 score is good, which is 87, and the low group precision is also good. So and if you want to take a look at the confusion matrix, this is the third table that I'm storing in the output. So this is the actual labels and these are the predicted labels in the rows. So like I said, the test set had around 24,000 transactions, and we were able to classify like 72 out of 125 correctly for the fraudulent ones. This was a very simple model, and certainly we can tweak this model and train this model again on this train data set to even improve our scores on the test set. And what we did here is we trained a model on 2 months worth of data. And what we are going to see next is, once this model is deployed into production, how does it do well or not on the unseen data set. So like I said earlier, we have data for 3 months, and we have only trained it for a couple of months, and we are going to use the next month for doing the inferencing or the predictions by generating the scores on this unseen data. So I'll be covering how to deploy the model in the next video. Thank you for watching this. Thank you.